Chapter 4, Section 5 is on exponential and logarithmic equations. I do want to point out this conversion equation that we did in the previous section. Any exponential equation, if it has the three components of a base, exponent, and an argument, you can rewrite in logarithmic form. That's going to be key. Put this formula on a note card and look at it until you have it memorized, and you can go easily from one form to another. The equation that we have is 4 to the x is equal to 29. This has the three components. The base b is equal to 4, b is equal to 4, the exponent t is equal to x, and then the argument, the only other number left, we call that an argument. Argument r is equal to 29. So anything that's written in exponential form that has those three components, you can rearrange them into logarithmic form. So you're going to write this as the logarithm. The base is 4, the argument is 29, and that is going to equal the exponent x. And now that we have the equation, solve for x is equal to log base 4 of 29. Use the change of base formula here to find the value of log. Log base 4 of 29 is the same thing as log of 29 divided by log of 4. Alright, so by converting the exponential equation to logarithmic form, we rewrite the equation and solve for x. X is equal to log base 4 of 29. Now the change of base formula says you can write this as log of 29 divided by log of 4. Let's choose our answer and check. Okay, let's look at now number 2. Similar type problem. For the equation, give the exact solution similar to the forms explained in your book. We want to solve the equation 1/2 to the x power equals 11. This is written in exponential form. The base is equal to 1/2, the exponent is equal to x, and the argument is equal to 11. So the base b is equal to 1/2. The exponent t is equal to x, and the argument r is equal to 11. So we have base to the x power equals 11. Rewrite it in logarithmic form. So it's written as log base 1/2 log base b of 11 is equal to x. Log base 1/2 of 11 equals x. So if x equals log base 1/2 of 11, use the change of base formula to write this as log of 11 divided by log of 1/2. Actually, I don't even need to go that far because one of the choices is x equals log base 1/2 of 11. Let's check our answer. Okay, so this one was a matter of simply rewriting it in exponential form. Now the next part, it says choose the solution of this equation similar to the form log y over log a. Alright, so in this part, log base 1/2 of 11 can also be written as log of 11 divided by log of 1/2. Log base 1/2 of 11 using the change of base formulas, log of 11 divided by log of 1/2. Go ahead and check your answer for that one. And then the last part of this is using the alternate form of the change of base formula. Log of 11 divided by log of 1/2 is the same thing as the natural log of 11 divided by the natural log of 1/2. So you can either write log using the change of base formula or the natural log. So make your choice and check your answer. Let's look at number 3. For number 3, you want to find an approximate rational solution to this equation. 2 to the x equals 9, and we're going to round to 4 decimal places. This is in the form of b to the t equals r, where the base is equal to 2, the exponent t is equal to x, and the argument r is equal to 9. We're going to write this in the form of a logarithm. 2 to the x equals 9 can be rewritten as log base 2 of 9 equals x. And that is so key to be able to make that transition from an exponential equation to a logarithmic equation. Now you do have x by itself. X is equal to log base 2 of 9. Using a calculator and the change of base formula, we're going to write this as log of 9 divided by log of 2. Okay, so on your calculator, determine the value of log of 9. I'm closing the parentheses and then dividing by log of 2. And we get, as a decimal, we get 3.169925001. Rounding this to 4 decimal places, we get 3.1699, 3.1699, and we can check our answer. So the way to solve this one is to convert to logarithmic form and then use a calculator to evaluate. Okay, let's look at question number 4. We're solving this equation by converting to exponential form. 1/5 to the x power equals 9 can be written as log base 1/5 of 9 equals x, using that conversion equation. Now we have x equals log base 1/5 of 9. Use a calculator and round to the nearest thousandths. So we're going to find log of 9 divided by log of 1/5. Using the change of base formulas and a graphing or scientific calculator, evaluate log of 9 divided by the log of 1/5. Okay, we get as a decimal -1.365,212 the nearest thousandths. Well, the tenths is 1 decimal, hundredths is 2 decimals, thousandths is 3 decimals. So we are going to round this to -1.365 as our answer. And check. Let's go on to question number 5. Question number 5 is another exponential equation. 0.7 to the x power equals 6. 0.7 to the x power equals 6 can be rewritten as a logarithm. Logarithm, the base is 0.7. The argument is 6. That has to equal x. So if x equals log base 0.7 of 6, using a calculator, we're going to evaluate log 6 over log of 0.7. That's the change of base formula. And we're going to round this to 4 decimal places. Log 6 divided by log 0.7. And we get -5.02350. And we're supposed to round this to 4 decimal places, which will give us our final answer of negative 5.0235. That's our answer. And check.